A large AI model requires more than 10,000 servers, 4 of which are installed in one rack. Each host is divided into 3 layers, upper and lower. It is larger than a home desktop computer, with 8 processor chips on the upper layer and 8 processor chips on the middle layer. 32 memory sticks are inserted in the middle, and 19 hard drives are arranged at the bottom. The processor used in AI servers uses GPU chips. There are 6 high-speed memories around the chip. It is stacked by 12 layers of DRAM chips to form an ultra-large capacity memory. Cube memory particles are placed close to both sides of the processor to achieve high-speed transmission. An extra silicon substrate is added to the bottom of these chips and is filled with sodium. Nanoscale integrated circuits that provide high-speed connection transmission speeds for memory and chip data exchange. The speed can reach a terrifying 1.2 terabytes per second, which is 3 times that of DDR5 memory. The triple middle layer is DDR5 memory stick, 32 in total. Each stick has a capacity of 128 gigabytes total capacity for 4 terabytes. Its hard drive uses the same chip used in home solid-state drives, which is fast enough, but the capacity is not enough. In order to expand the capacity, server hard drives use larger motherboards to accommodate more storage particles. The host has 19 hard drives, each with a capacity of up to 30 terabytes. Finally, with the help of the advanced PCI Detection 6 protocol, the massive data transmission between it and the memory becomes unobstructed. However, for the short video platform server, it also needs to be equipped with an independent email server. Hard drive rack. This kind of hard drive has a larger capacity. One specification is 122 gigabytes TB, the other one is 246 TB. The entire rack can store hundreds of thousands of TB of short video content. So, why does the AI host need so much memory? To put it simply, the job of AI is to unconditionally execute your prompt word instructions. His understanding of each word requires approximately 8,000 bytes, usually labeled. The entire process of a token will quickly match and analyze all associations of this word. Therefore, the understanding of just one vocabulary will generate 8 kilobytes of data. In reality, AI not only needs to understand the relationship between words and the entire text, but also actively understands the relationship between the text. Actively learn the content of previous conversations. A simple command will generate massive amounts of data. Next, AI will send hundreds of thousands of tokens to hundreds of conversion models. In the module, each module consists of tens of millions of learning parameters. The learning parameters of the entire artificial intelligence model can reach hundreds of billions. When a piece of prompt word text goes through hundreds of billions of parameters of the entire model, the massive data generated will be processed through the AI processor and memory. Frequent communication. This is why AI servers require so much memory. Storage capacity in home computers is small, but there are many types. When you open a program, the data on the hard disk will load it into memory, graphics card memory, and CPU cache. After everything is loaded, your screen will display a delicate and smooth picture if there is only a single memory like the server. So no matter how high the configuration is, there will still be delays and freezes in the screen. Among all memory chips, the one with the fastest access speed is the one built into the CPU. The cache takes the Intel i9 processor as an example. It has 8 large cores and 16 small cores inside each core. It comes with level 1 cache and level 2 cache, as well as level 3 cache placed in the channel. When the CPU core calculates cache, it will first access the first level cache with the shortest distance. Secondly, the larger the cache capacity of the second level and third level caches, the greater the distance. When the third level cache is not enough to store, the CPU will go to the memory stick to extract data. The memory capacity is larger. The current mainstream configuration is 32 gigabytes, which is 470 gigabytes of CPU cache. There are 8 chips in one memory of the device. These chips pass through the motherboard's internal memory. The memory channel is connected to the CPU's memory controller and opens a memory. Inside the particle is a multi-layer conductive plate and a memory chip. There are 32 libraries, each of which has 65,000 rows and 8,000 columns. A memory cell array composed of a single cell consisting of a transistor and a circuit. Composed of capacitors, each capacitor stores a bit of data, and the transistor is responsible for transferring data to the capacitor. The entire process of reading and writing the data is sent by the CPU, and it will be accurate based on the address. Access to the corresponding capacitor. Once the power is turned off, the stored data will be completely all disappear, and all the data in the memory comes from the hard disk. The hard disk must go through the memory too. Can be read by the CPU. This is a 2 terabytes NVMe solid-state drive. There is controller, memory chip, and 2 1 terabyte storage chips, all files of the computer. The keys are all stored in it, which is composed of 8 flash memory chips stacked on top of each other. Each floor is divided into 2 units, the left and right units. Each unit is a huge storage unit. Memory cell array, which consists of 40,000 strings, 60,000 rows, and 200 floors stacked. A thin piece can store 100 gigabytes of data. Let's go ahead and zoom it in, and it's lined with storage called charge traps. Each unit has 8 rooms. Each room corresponds to a 3-digit binary number. These rooms store corresponding data by capturing electrons. The right data is fed into the electronics by the charge trap in the middle to read the data. Is obtained by measuring the number of electrons in each room. Among all storage devices, mechanical hard drives have the slowest access speeds. Inside it are 4 stacked platters and 8 read and write heads. Each platter has 500,000 concentric tracks on its surface. Each sector will be automatically generated. Each sector has a code, an address, a 4 kilobyte storage area, and an error correction verification code. If you zoom in on it, you can see that the magnetic head writes data by changing the direction of the magnetic field within the square unit. Reading data is through the magnetic head sensing the changes in the magnetic field between the blocks. If there is a change, it will read as 1. If there is no change, it will read as 0. The most precise component of a mechanical hard drive is its magnetic head. The magnetic head needs to fly in the air 15 nanometers above the disk and needs to pass. Find the exact address on the disk through displacement. However, due to the limitation of disk speed, its access speed is far inferior to any other digital technology.